Well, first of all, thank you everyone for coming. Welcome to MongoDB, New York City. Thank you for being up so early this morning, braving the rain, being here. It's going to be worth it. We're going to have a very incredible day. So let's get going. First, a little story. Many years ago, when I started my career, there were only two ways you could reach someone by phone. You could call the person at home, or you could also call them at work, on their phone at work. But these days, how many of you still have a phone at work? Oh, we still have a few, okay. But there's less and less. Today, a person has a cellular phone, a Skype ID, a Messenger ID, a Zoom ID, and God knows what, next month. So, if this is great for most of us, we can reach each other, get better communication. It's not that great if you did this kind of design many years ago. I did. There were only two ways you could reach someone. So we would have a table, we will model a person, we'll have one column for the first phone number, another column for the second phone number. So obviously, if your system was successful and you have to migrate that to more modern stuff, you would have issue. How would you do that? Well, welcome to my talk. This is what we're going to be talking about today. We're going to be talking about how we can prevent such problems. We're going to talk about data modeling. I'm Daniel Coupal. I've been with MongoDB for 9.5 years. Some of you may know my work from the data modeling blog series, the anti-patterns I've wrote, or the data modeling class that I put together for the university. Well, I'm passionate everything about data modeling for MongoDB. So our presentation today will be divided into three sections. First, we'll talk about the need to model for not just for MongoDB, but for NoSQL. Then we'll get into how we do that. We'll introduce a very simple methodology, talk about what's important when we model. And then I'm going to dive a little bit more in details into one of the schema design pattern that is extremely important for MongoDB and is going to solve some of the problem that we saw with the model in the story. So we have a lot to cover. Let's get going. So first of all, we model because we face an answer to constraints. If there were no constraint, if everything was super fast, we could just retrieve the information from wherever it is, we wouldn't have to model, we'd just get it. But that's not the reality. We do have physical constraint. For example, the network latency is not zero. And it grows as the distance between your application and the server grows. You do have constraint with the hardware. Hard disks are pretty slow. RAM is faster, but much more expensive. We can't have machine with everything is just in RAM. And also, you do have constraints that are put on you by the software you're using. Whether it's the database, the OS, whatever, there's a lot of functionality available, but it comes also as a cost of having some constraints. So, when we develop an application with MongoDB, we're going to basically have three layers. We're going to have the application talking to MongoDB, then talking to whatever MongoDB does. And for example, if you're using Atlas, you're going to be talking to the cloud provider. It's going to be AWS, Azure, or GCP. What interests us, obviously, for this presentation is the model part with MongoDB, the constraint that MongoDB will bring. So, because we do have constraint, we also have all these functionality that come with the product. And it's imperative to know the features of the product you're using. So in the case of MongoDB, for example, when I joined the company many years ago, MongoDB was built on the document model. We had rich indexes, we had sharding, replication, and so these were all functions that I could take advantage of when I do my model. Now, a few years later, we have transaction, we have field-level encryption or queryable encryption, we do have data federation, archive. A lot of features have been added to our products over the years. But what's the effect on modeling? if I had done a design many years ago and I needed a transaction, I could still do it by a double commit. Now that's pretty difficult. You don't want to do that if you can avoid it. Now MongoDB offers transactions. They're pretty much like the native transactions that we get with SQL. If I wanted to create encryption on my field, I could have separated the data in a way and manually encrypt things and keep all my keys. Obviously, using MongoDB these days with field level encryption make things much easier, and etc. We have Data Federation Archive that's going to help you archive data in a much easier way. Search with the Lucene search engine through Atlas Search instead of doing just regular regex. So the key point is it's important that you know the basic features that will affect your modeling. So for this presentation, we're going to use a little example of social networks for chef. Or chef's going to be writing articles, recipes, and then we're going to categorize these articles, put tags on them, and we're going to have users who are going to come and comment on those publications, all the articles. So if I ask you to model that social network in a relational database, you would get something like that. So we would have people who are writing one too many article, writing one too many comments, and you'll get one too many comments associated with the articles, and then the many too many relationship with your tags and categories. The interesting thing about this model here is if I ask all of you to do it, you'll probably all come up with that exact solution. And the reason is once you've established what the relationship between the piece of data you have is, if you want to normalize something to the third normal form, there is only one solution, and that's it. Now let's do the same exercise with MongoDB. Let's say that our system cares about articles. Most of the queries will be about the articles. So someone will come with a solution where we have one collection for the articles, and we're going to embed all the information inside. Or someone may say, hey, if I do that, the information about the people is duplicated, so I don't want to do that. I'd rather be able to do only one update for my people. So I'm going to have another solution where I'm going to extract the people, collect information, put it in a different document, different collection, and then I'm going to have a one-to-many relationship. So two solutions, which one is the best? Well, the answer, it depends. If you're able to manage the duplication of information, the first solution may be better because you're going to do only one read to retrieve the information. You'll get better performance. But if managing the duplication is a problem, then the second one may be better. So what are we saying here? We're saying that you can only determine the optimal grouping of your objects into collection if you understand the workload. And that's going to bring us to the second part of our talk, where we're going to introduce the methodology that's going to drive us address the information about the workload. So that's the first thing we want to do. So there's like three main parts when you model with MongoDB. First, you need to identify the workload. Then you need to identify the relationships and model them, and then you apply schema design patterns. So for those of you who are familiar with relational database, you probably caught on something here. It's like, hey, in the old days, I will go with the other data architect in a room, and we'll draw the ER diagram, then we will go to our desk, write the code, something doesn't work, we will denormalize. Fine. But when you work with MongoDB, we just said, yeah, you need to understand your workload first, and then you do your data model. And this is not because you're modeling with MongoDB, it's because you're modeling for NoSQL, because you're modeling for a modern world where the solutions are much more different than what we had in the past. We have an amount of data and we have requirements that are so much different in terms of performance these days that any solution that requires performance, you really want to understand how you're going to be using the data. So that first part where we want to identify the workload, we're going to size the data. That's going to help us understand how much hardware we're going to need, number of disks and things like that, give us a an approximation of how much this thing may cost, and right away point at some information if something looks too big. We're going to quantify the operation. So my write and my reads operation, it's not just about knowing what they're going to be retrieving, but how many times per second are we going to run them? What's going to be the latency of some of those queries? That's usually a top requirement to be sure things come back fast. And we can also qualify the operations. By qualify, I mean there's other aspects of your operations, like security, for example, that you want to think about as early as possible, because that's going to have an impact on your model. So let's go back to a little example. Let's write some of the main operation for our systems. 2 write operation, 2 reads operation. My first write operation is going to be the one where my chefs are publishing something. So we're not going to get that many of those per day, but if we have to list how critical it is, that's the main piece of our system. We don't want to lose that. You want to be sure that in any kind of issues happening with the network, the machines, that you're not losing them. Then we're going to have comments coming from our users. Important too, we're going to get a lot more of those. So it's an order of magnitude more writes than our articles. And then we're going to get some read operation. The next one is people reading from our site. And you can see here, it's all again another order of magnitude, much bigger. And then we may have analytical requests. Listing those is important, understanding those at the beginning of your project, because that's going to also help you understand that maybe some queries should not be running where you're doing all the writes. Maybe you need an analytical node for those. So out of listing your main operation, there's something that's going to come out, and most of the time you're going to end up with 1 or 2 operations that are so much more important than the rest. So in our case here, we see that the number of reads are really what's going to be important. That system only makes sense if people who come to the web page get a result very quickly. So we want to be sure we can load that page very quickly. That's going to be the focus of our model. So for those important information or operation, what we want to do is dig a little bit more into them. We want to have more information about, for example, is it subject to GDPR, the right to be forgotten? What's the data lifespan of that? Some of you work with financial institutions. There's something that comes up very often when I do reviews with them is you want to keep the data hot for maybe 2 years, and then after that it still has to be available for another like 5 to 8 years. But if you can archive it somewhere else where it's cheaper, you also save, because over 10 years you get a large amount of data, and you may not want to pay for the disk and the RAM needed for that all the time. So understanding those right at the beginning is important. As a result of the book that I wrote with Steve and Pascal, we collaborate, and on the right-hand side, you see here a screenshot of Accolade. It's my favorite modeling tool. I'm a little bit biased, but it is. And in the tool, there's a way you can describe your queries, and that's going to be captured. You can save it. So it's pretty cool enhancement. It just came out last month in that tool. Really love it, because that's basically a way you can capture things. And that comes to my next principle here. We can only act on new hypotheses if we know the original hypothesis. What I'm saying is, if you don't understand that you thought that the system was going to handle 1,000 writes per second, and you see 3,000 when you go in production, you may not really understand all the implication of that. But if you've written it down and now you see the number, then you can revise the right part of your model. So out of that first phase, we have a good understanding of what our system is going to do. So we're in a good position now to understand how we're going to put the information together. So we're going to identify the relationships, and here, again, the relationship between pieces of data, they're always the same. Either you model for a relational database, you model for MongoDB, you have a one-to-one, a one-to-many, many-to-many. You need to identify those. They're just going to be modeled differently when you work with MongoDB. We're going to quantify these relationships. What I mean is many sometimes is not enough when you model in the modern world. think about a social network system like Twitter. So a person may have 1 million followers, for example. Well, you wouldn't take 1 million followers and embed them into an object. That object will be way too big. So there's a better way to quantify, and it's important if your system deals with a huge amount of data. So if a favorite representation of me is you model by saying this is the minimum, like 0, 1, my maximum is 1,000, and the most likely value is 10. So when I see these three values together next to a many relationship, I have more information and know what I can do with the data and what I cannot or should not do. And then once we have this information, the next step will be to decide if we're going to embed or reference the information. And that's probably the most important step you're going to do for all this modeling process. And there's an analogy I like is if I have a car and at the end of the day I come back home and my garage is my database, it's a relational database. As I park my car in the database, I would take the wheels, put them on the table. I will take the seats, put them on another table. I will take the brakes, put them on another table. If my garage was MongoDB, I will come in the evening, open the door, put the car in the garage, and the morning after, when I'm ready, I get the car out. So what we're saying is MongoDB, when you use with MongoDB, when you model, what is used together in the application is stored together in the database. So no need to redo joins between pieces that you always reassemble together anyway. So they stay together. Okay, just to be sure that we make the point of referencing and embedding clear, let me give you some example that relates to the relational world. So we have a relationship between two entities. It's a one-to-many articles and comments. In MongoDB, if we say we're going to reference the information, we're going to have, similar to what we have in a relational database, we're going to have an ID that's going to point to another document, and that's how we're going to be able to do it. And you can use a $lookup in MongoDB to do the join. But doing joins is really expensive, as everyone knows. In SQL, that's very, very expensive operation, and that's why you should try to avoid them. And the other alternative of representing this one-to-many relationship is to embed the information. So when we say we embed, we take the second entity, we put it inside the first one. And if it's a many, you're going to use an array. An array in the document model is the representation of a one-to-many relationship. And you can see here the three numbers, which here means that my comments for this article will be a minimum of 0, a maximum of 1,000, and then most likely 50. That gives me a good understanding of how big the things is going to be. Okay, so let's go back. So I said that the most important question to answer is if you're going to reference or embed. So recently we come up with a list of questions that makes you decide, be able to answer that question a little bit better. But at the end, the essence is what we have here. If you have two entities and the relationship between the many is really big, we're talking about, for example, the Twitter users, well, you don't want to embed. In this case, you'll probably prefer referencing. If you have a many-to-many relationship, and for your write operation, it's going to be much easier if you keep things in two different documents than if the thing is copied all over. That said, you can still use a transaction. MongoDB supports transactions, and you can still do it this way. If a piece of information, let's say we have two entities and we need all that information, but there's only a small section I'm using all the time. The rest I'm not using it. In this case, if memory is really important, these are large objects, you have a lot of them in memory, you'll probably reference. So you'll break things in, you'll keep in one document the information you're using all the time, and you'll keep in the other document the things you're using less. On the other hand, when would you embed? Well, for integrity on the read operation, for things that are read together, my car, I need all the parts together all the time. So if I embed that, I do only one read from the disk, no join, and they have all the information. Sure, again, you can use a transaction if you want, but the point is your most important operation, you should avoid transactions because they add a lot to a lot of resource consumption for it. And MongoDB is really designed to get you the best performance when you work at the unit of the document itself. Another one is if I have a one-to-one or one-to-many relationship and I embed the information, I can write that together on disk as an atomic way. MongoDB always supported ACID at the document level, so we can do that. If data is deleted or archived together, think about cascading delete that relational database support. Well, MongoDB supports it in a way that if you delete a document, if I delete an article, all the comments associated to it also get deleted. Now, on the archive one, we talk about financial service. If a piece of information has to be archived, if it's kept together in one document, and I archive the document, 5 years later, I can go read that document and it makes sense by itself. Think about how difficult archiving with a relational database would be. I have a customer I need to archive. I would need to archive the table for the customer, but all the other tables that I do joins with usually to group the information. But in our case here, because the document model is rich, we have a combination of sub-documents and arrays, all the information about my customer reside in one document. So if archiving is something super important for you, you probably want to embed the information for these pieces that you want to archive together. And then the final rule is by default. If you embed things, the objects are more likely to look to what you have in the code, and that's going to make your code much simpler. There's no transformation, reading from the database, assembling things, and storing them back. Okay, so coming out of that second phase, we already have a good model, I think, at this point, but we can do better. And this is where we're going to apply patterns. Patterns are transformation that's going to help make our things more performant, easier to manage, etc. So we're going to identify the places where we may apply a pattern, and then we're going to apply it. So all the cases that when we try to decide if we're going to embed and link, and we had conflicting rules, it was not clear which one we should be doing, those will be very good candidates to get patterns being applied to those relationships. So we liken the patterns to that book that's been published many years ago by Irgama and the Gang of Four. So what this book was doing for software engineering is what we're trying to do with our patterns. This book was not just about giving you solution, but more about giving you a common language. Anyone who read that book and went to a meeting with other architects and start talking about using a factory, FSA, an observer, singleton, they knew exactly what the other person was doing, what they wanted to, what was the intent, because it was well defined in the book. So this is what we're trying to do with our schema design pattern. So you guys are the first large audience to which we say that. Because of the book, we did some additional work, so we revamped the patterns. So we added some patterns. We went from 12 to 16, and this is our new list. So you're the first one to see them. Now, I don't have a ton of time to go over all of those. I'm going to give you reference to know more. But let's quickly have a little description of a few of them and how they would apply to our solution. The first one is called an extended reference pattern. Let's say that we have a situation where we're not sure if we're going to link or reference, and we decided to reference. Well, if I decide to reference, does it mean that I'm going to have to do a join, a dollar lookup every time I run the query? If it's an important query, it's not going to perform the way I want. I'd rather do one read on disk, get all my information. So if you think about it, I wanted to keep the people separate, but in order for me to display an article, I can bring a little bit more information than just the reference to the different people who work on the article. So in this case, what I'm going to do, I'm going to bring the name of the person, and only in the case where the user wants to know more information can click on the link and then they're gonna get the full information about the person. Then we're gonna fetch that from disk at that time. So basically, what the extended reference is instead of just keeping a pointer back to something else, bring what you need to avoid doing joins for your most important queries. Another one is called the computed pattern. An important thing on, let's say, the main page for the article may be to display how many comments we have. Well, if I'm going to count the number of articles every time, it may not make sense. You saw the number of the read and writes we have. We have like 1,000 times more reads than writes. So my number of comments on the article is probably not changing often. It's 57, user com, and it's always 57. So instead of having to do this computation, which is exactly the same one all the time, what we're going to do is we're going to pre-compute that value when we have a new review, and we're going to add it directly inside the right place. And because the document model is rich, I can put it wherever I want. I can put it in the subdocument. I could put an array of these values over time if I want. So that's going to prevent me to use resources that do the same thing all the time. The next one is called the subset pattern. And it's something that you see often in things like Amazon. You get a list of comments. A product may have 1,000 comments, but no one usually is interested in reading first 1,000 comments. And a lot of people go see the product page or the article in this case with the intent to see something else. So what's the point in loading all the comments if it's not useful for them? And what's the point again of doing a join if I'm always going to do the same thing? So what the subset pattern is going to do is look at my documents where all the comments for this article are, and it's going to just take maybe 10 of them, maybe the 10 most relevant, the last 10, and it's going to copy that inside my article. So you see where I'm going here. I just need to do one read of my article document, and I get all the information to display my web page. It's going to be much more performant than doing how many reads would you need to do to join all the information. And finally, the last one is the schema versioning pattern. And it's as simple as having a schema version number in your document, but there's some work associated that you're going to have to do in order to manage that. And that's going to bring us to our next section, which is evolving the model with a schema versioning pattern. First of all, if you have to do that, if you have to evolve your model, great for you. You had a successful system that lived for a long time. If I had to update the system that I was talking about at the beginning of the show, it means that this application was successful. So any successful system will go through changes, likely including data model changes. And those changes are typically of twofold. The first one is a field modification. Relational database do that very easily, alter table, add the thing. And the second one is you need to change the relationship. And this is exactly what we had at the beginning of the talk. And we're gonna go and do that. So that was the first version of our schema. And we had two users. They had a home phone, a work phone, and then we got a new user, and that new user has a little bit more information we didn't know how to store. So we decided that we're going to refactor our database, and we're going to break up the people collection, and now I have a communication table, which can make things a lot more flexible. I can include new mode of communication. I'm going to have a relationship of one-to-many to that. And the way I'm going to do that, if I have a relational database, on Friday night I'm going to bring my system down, and then on Monday morning I'm going to have two tables instead of one, and then the system's going to go up. So I'm going to reformat all my data to go from one table to the two tables, update my applications, everything is good, we're ready to go. Let's do the same thing with MongoDB. So we have our third user, Alton, who has a little bit more information than the other users. So we want to go to that one-to-many relationship. Here I'm using the embedded solution. I could have reference. It would be exactly the same thing. So the magic happened because of the version number we're going to put in the document. When you have a relational database, you have one version number for your schema. But with MongoDB, we're going to piggyback on the polymorphism aspect of the document model, which say that documents can differ a little bit from each other, and they still reside in the same collection. We can still make queries on them. So we're going to have every document carry its own version. Every document has a schema version that way. So that means that on Friday evening, I have 3 documents. They're all on version 1. And on Monday, I want to have all my documents in version 2. So I can go and update the documents one by one. They don't have to be done at the same time. As long as I modify my application first so it can read the documents in version 1 and read the document in version 2 and handle them correctly, it doesn't matter at a given point in time if they're all in V1, all in V2. So that means I don't need downtime. So MongoDB lets you develop and deploy quickly, but also lets you evolve your application and schema quickly. So that brings us to our conclusion. So there were 3 sections in the presentation. The first one was talk about the need to model. So things we got out of that. It's imperative to know the features of the product you use. So MongoDB is very rich. We're adding new features. Get to know, especially the one that affect data modeling. The optimal grouping of objects into collection is determined by the workload. So that's really your cornerstone. You need to understand your workload in order to do a performance solution with MongoDB. And then we introduced a little methodology in our technique to model. What we get out of that is we can best act on new hypothesis if we know the original hypothesis. So write down the things that you assume your system would be using or would be working a certain way. And what is used together in the application is stored together in the database. So that's going to be the main rule to help you decide if you're going to embed or reference things. And finally, we talk about the schema versioning pattern. Any successful system will go through changes, likely including data model changes. And MongoDB lets you develop and deploy quickly, but also evolve your application and your schema quickly. So to know more, you can Google me. I've written a series of blogs on patterns and on anti-patterns. Anti-patterns being what you should not do. Atlas auto-detect a lot of these situations. Those blogs are a little bit old, so there's better way that's going to come to learn about them. Next thing is MongoDB University. How many of you are using MongoDB University? I've done courses on Mongo. Well, that's not a lot. It's probably, I think there's more people who have a work phone than people who are using MongoDB University here. MongoDB University is free. We're not there to make money out of the university. We know MongoDB is a different paradigm. We want you to be up and running very quickly with the right information. So courses are free. Please go register. We've revamped all the courses in the last about year and a half. 2 of my favorite courses. One is called M100. If you're coming from the relational world, it's a very short course, 2 hours, no homeworks, promise. And we just translate your knowledge from what you know in relational to MongoDB. And then if you want to know more, dig into data modeling, we have this course M320. It's been there already for a few years. We're revamping it right now. It's going to come out in a few weeks. We're just finishing the recording in the edition of these videos. So look for that. And finally, the most up-to-date piece for the data modeling on MongoDB and all our patterns is this book here that just came out about 2 weeks ago. A book that I co-author with my 2 friends here, Pascal Desmarais and Steve Oberman. Pascal is the owner and the brain behind Accolade, the best modeling tool out there. And a lot of you may know also Steve, which has been one of the guru in data modeling for SQL database for so many years. So you'll probably get access to the slide if you want to take a picture. I'll leave that for a few seconds. And about the data modeling course, data modeling book, we're gonna have some giveaway this afternoon. We're gonna have a signing session, and we have a bunch of books that's gonna go out for free at the same time. So please find us. I am not sure exactly where it is, but it's small. Sorry? Spotlight Lounge? Spotlight Zone. So this is where it should be. So thank you everyone for your time. We do have about 5 minutes if you guys have questions. Someone should probably have a mic. Oh, okay. Maybe I can repeat the question.
My question was about the extended reference pattern.
Yeah.
I deal with a very large corporation. People's names change, so I have a large store of documents where I've got their ID and I've got their names embedded.
Yeah.
So I've never used Mongo. Do I need like housekeeping routines to kind of go through?
That's a good question. Yeah. So the question here is regarding the extended reference. If I use, for example, in the extended reference, the name of the person because I don't want to have to join it and it's important, and avoid doing the join. What happens if the name change? Yes, a lot of these patterns may introduce some data duplication, and there's going to be some maintenance in some cases. There won't be maintenance in other cases. There are cases where data duplication is better than no data duplication, but if there's data duplication, it's always something that you need to evaluate. What is the cost? Because you can still do an update. If the person changed the name, you're gonna have a little thing that may check for that. You may have a change stream. Do I have an update on name? Yeah, I'm gonna run a script in the evening. Doesn't have maybe to be done right now. I'm gonna update the information. In the case of, and as I said, there are cases where data duplication is better. Think about an invoice in which you put the address of a customer in it. If the address of a user change, you want the invoice to reflect the address at the time of the person. So in this case, the fact that we embed what we need from the customer inside the invoice, it's going to be frozen in time. And in this case, it is data duplication, but it is better than no data duplication. But to go back to the answer, yes, some patterns will introduce data duplication or other things, and you need to manage them.
Can you hear me, or do you want me to come up? Yeah? So, first of all, thank you for the talk. So the main benefit of MongoDB versus typical relational SQL databases, performance gains, performance benefits, is that correct?
So comparing performance of MongoDB versus a relational database?
No, the main benefits. The main benefit that we're looking at is performance.
Well, when relational database were designed, we were really expecting that, it's a long story, but you can go see Rick's Hooligan talk this afternoon on that. It's incredible. But the essence of it is, in the relational database, everything is based on the joins, and the joins are really expensive. If you think about it, you need a lot of CPU to do those joins, and once you've resolved that, you still need to go and read. If you have 7 joins, you're going to read like 7, 8 pieces of information on disk, so that's 7, 8 reads to put them together. So performance, you can't expect no relational database to perform as well as the NoSQL solution, the modern database we have these days. In MongoDB, if all that information is in one document, I do one read and I have everything. So I would say this is where you get the best performance, versus a relational database. Now, what is the main advantage? That's one. A lot of people will tell you that. One of my favorite one is the schema versioning pattern that I put there, because this is the world in which we live these days. Is we cannot have downtime, and the fact that I can change my schema in nearly any ways, and I'm not going to have downtime. I can have a strategy that's gonna keep me up, and it's not that much work. To me, this is worth a lot. You know, as engineers, we like designing solutions that are complex. We like beauty of stuff and all that. But we've learned, if we have experience over time, that what's the most expensive thing in systems, it's really the maintenance of the system. So if you can add a field easily, you don't have to rebuild a schema. You don't have to bring things down. This is, I think, where you get the most value. So for me, I will say the document model of MongoDB, which is the essence of being able to do these updates, it's the most important feature of it. Okay, thank you everyone for coming. I hope you have a great day. We have a lot of great content coming up, so stay in and go to the end of the day. We have some beers at the end of the day, so it's worth staying till the end just for a beer.